All right, so this week we're going to be taking a look at two sections, 4.4 and 3.3, in two totally separate sections. This will be the easier one of the two, and the test will focus on this section. Okay, the harder section we're going to spend the rest of the week on after today, but I'm going to limit the number of problems from the harder stuff on the test. All right, so let's just start out with the formula for area of a triangle that you learned back in geometry. Anybody remember the formula for area of a triangle? Yeah, Jake?
Is it half the base times the height?
Yeah, it's half the base times the height. So we're going to build on that a little bit. And if you have the base and the height, then you don't need to. You've got everything you need to answer the question. But I'm going to give you guys a problem like that. You don't have to write it yet, but we'll do it in a little bit. And the problem here is you don't have the base or well, you have the base. I guess you could view the 4 inches as the base. But the height would really be something like that. That's the height. And we don't know the height. Okay, so when we get to this problem, we're going to look at a different way to solve it without having the height. I'll show you what that is. And I think I have another one. Here's another one. A little bit different. Again, you've got the base, it's 4 feet, but you don't have the height here either. Okay? You have all 3 sides. The 5 is not the height. Okay? The 5 is a little bit slanted. You'd have to go straight up and down to the height. But as long as you have all 3 sides, or if you have 2 sides and an angle, you can find the area. Right? So those are the 2 types of problems I'm going to show you how to do. All right. So let's start by taking a look at this. All right. So let's kind of break it down. All right. So what I've drawn here is a triangle. I'm not going to label everything because I'm not going to use everything. I'm only going to label what I'm going to use. I've labeled the bottom side as B. I've labeled the side that's on the left as A. And I've labeled the angle between A and B using this symbol. Anyone remember how we say that one? Yeah. That's gamma. Very good. Okay, so that angle is gamma. Now, the formula that we're used to using to find the area of a triangle has this in it. Has height. Well, I don't know the height of that triangle. This is the height. It would be a line from the highest point straight down perpendicular to the base. And I'll just label that H. And it's perpendicular, so we can put that little symbol in here. So, if I wanted to find the area of this triangle, let me look at what I know. Well, the 1/2, that's just a number, so we got that. The B, we could be given that information, and you usually will, but it's the height that we don't know. So, we're going to come up with a way to find the height. All right, so let's take a look at what we're going to use here. All right, so I have a right triangle, okay, right here. Just draw it in a different color so you can see it. Let's focus on using this, and that, those 3 things. All right, side A. Okay, that is across from the 90. Ben, what do we call the side that's across from the 90?
Or opposite.
We are going to use those terms. That's what I'm looking for. But the side across from the 90 isn't either one of those. The one across from the 90 always has a special name. Please.
Is it the hypotenuse?
It's the hypotenuse. Okay, so the side across from the 90 is the hypotenuse. Now I want to know the name of the side I've labeled H. from the perspective of gamma, and it's the side that is farthest away. Does anyone remember what word we use to describe the side farthest away? Yep.
Opposite.
Opposite. Okay, so in that right triangle, the two sides that I have labeled are opposite, I've labeled as H, and hypotenuse, I labeled as A. Opposite and hypotenuse. Anybody remember which trig function out of those three has opposite and hypotenuse in it?
Sorry?
Yeah, sine. Okay, so what we're basically going to do is make a formula to solve for the height when we don't have it. And we're going to fill that formula in right where I circled H in black. All right, so we always do sine of our angle, which in this case is gamma, equals opposite over hypotenuse. James, what side is labeled opposite here?
The H.
H over hypotenuse. What side is labeled as hypotenuse?
A.
A. Okay. Now, again, I want a formula that finds the height. So I want to get H by itself. So how about Autumn? How would I get this A on the other side?
Multiply both sides by 8.
Yeah, good. Multiply both sides by A. And there you go. There is a formula to find the height. A sine gamma equals H. This is gone. So now, instead of having to know the height now, you have a formula to find the height. A sine gamma. So we're going to take that, and we're going to fill it in for H, because it equals H. And that's going to give us a new formula to find the area of a triangle. So I already asked you guys that. The area is 1/2 base times height. If you're not sure what the B and the H stand for, I just labeled them right there. You could just label them if you wrote it down up above. All right, so if we have a triangle where we don't know the height, we need a different formula. That's what we're creating right now. Okay, so we already went through how to create the different formula. We just have to write it down. That's all we got to do at this point. So using the above diagram, we already went through all that. So now plug in A sine gamma for H. That's what we wrote down right here. Plug in A sine gamma for H. Now let's see what we got. So this, just draw it again, is going to go right there. So we have 1/2 B, that part, that's not changing, but we're going to change H to what we just calculated H is, okay, using right triangle trig, A sine gamma. Now, that's all multiplied together. If you were going to read that, you would say 1/2 times B times A times sine gamma. So you're multiplying 4 things together. When you multiply things together, Aiden, does it matter the order you multiply?
Yes.
So 2 times 5 is different than 5 times 2.
Not in that way. When it comes to like parentheses and longer equations, usually it does.
If it's all multiplication, even if you have parentheses.
You have double multiplication on there.
Yeah, if it's all multiplication, it doesn't matter. This is all multiplication. There's no addition here. There's no subtraction. There's no division. There's no exponents. There's nothing other than something times something times something times something. So if we're going to multiply 4 things together, what we usually do, just because I like to write it a little nicer, is we put it in alphabetical order. So instead of saying 1/2 BA, let's say 1/2 AB. So there's a new formula for the area of the triangle. where the height is built right into that calculation right there. So it gives you a way to find the height. Any question on that formula? Now, what I want to look at is kind of the pattern there. So let me draw just a general triangle. A, B, C, alpha, beta, and gamma. Okay, Cassidy, what's the formula we just came up with?
Which one?
For the area of a triangle.
A equals a half BH.
The new one we came up with.
B parentheses A sine beta.
And remember, we're going to rewrite that so it's like that. So 1/2 AB sine gamma. Okay, so let's just rewrite it like that. So that formula involves two sides and one angle. So that's kind of the pattern. To use this formula, you need two sides and one angle. Where is gamma in relation to the two sides that you need to use? James?
In between them.
It's in between them. So it doesn't matter what two sides you know, as long as you use the angle between them. So if you know A and B, great. If you know B and C, doesn't matter. If you know A and C, that works too. But the key is you have to know two sides and the angle between them. So based on that idea, anyone think they could give me a different version of the area of a triangle formula using two other sides and the angle between them? Yeah?
A equals 1/2 BC.
BC, yeah.
That's what we said. Sine and then alpha.
Alpha. So there's a second way you can use this formula. And there's one more. What would be the third way you could write this formula? Yeah, Vivian?
A equals 1/2 AC sine beta.
Perfect. It's not three different formulas. It's the same formula just written using different sides. And I have them all written out on the other page as well. Right here. Okay, so it's not really important to try to remember or memorize all three of those formulas exactly. What's important is just to memorize the idea. Area is 1/2 the product of two sides times the sine of the angle between them. That's what you want to memorize. 1/2 the product of two sides times the sine of the angle between them. Because you might be given a triangle that doesn't have any labels on it. So you're not going to know which side is A, B, or C. It might just give you one like this. Doesn't matter which side is A, B, or C. The point is you know two sides and you know the angle between them. Doesn't, you can call them whatever you want. But just plug those numbers into that idea. The area is 1/2 the product of the two sides that you know times the sine of the angle between them. Okay, so this formula works anytime you have to find the area of a triangle and you are given that information. Two sides and the sine and the angle between them. So now you got another way to find area if you don't know the height. Okay. Well, we'll try a few examples. One thing we want to remember, anytime you write area, how is area measured? In terms of like dimensions. Is area one-dimensional, two-dimensional, three-dimensional? What is area? James?
Is the unit squared?
Unit squared, right? That's two-dimensional. So if they don't give you a unit, do exactly what James just said. Just put u squared on the end of your answer. If they do give you a unit, like feet, your answer should be feet squared or inches squared. Okay, but remember, area is two-dimensional. Okay, everybody have that? Oh, here's a problem. Find the area of the triangle. So A is 8, B is 6, gamma is 30. Now, if we go back and check the previous page, A, B, and gamma, that is in one of the versions of our formula. I call that version 1. That's version 1. A, B, and gamma. Perfect. So let's set up the formula to find area. You're always going to start with 1/2, and you're always going to put two sides, and then you're always going to fill in times sine of an angle. So every formula that you do using the information here, you can set it up like that every time. Now we just have to fill it in. How about, Randy, can you tell me what's going to go in those first two parentheses?
So the first one has 8,
Yep, so we got 8,
and then 6,
and then 6,
and then 30 degrees.
and then 30 degrees. So 1/2, the product of my two sides, times the sine of the angle. All right, so let's do it out and see what we got. We don't have any units on the sides, so we're going to put u squared and final answer. Let's see, Ava, what's 1/2 of 8?
4.
Times 6?
24.
24. Good. So 24 sine of 30 degrees. Okay, at this point, we'll just we'll type it in on the calculator. What do you think? I want to check before I start even typing things in on my calculator. Pete?
Check the mode, check if the mode is right.
Yeah, we want to check the mode. Okay, so I can see on my calculator, I'm already in degrees, so I'm okay. Every area problem that gives you an angle will be in degrees this week, and on the homework and on the test. All right, so keep it in degrees and type in 24 sine 30. Hit enter, and we get an answer of 12. Most answers aren't going to come out nice, but 30, the sine of 30 is 1/2, and then 1/2 times 24 is 12. All right, so we've got 12, and how about, Don, what should I put on that, because it's an area?
Unit squared.
Yep, unit squared. Okay. Any questions on that one? Okay, let's try. Let's try this one. Okay, a little bit different because this time they haven't told you what's A, what's B, and what's alpha or beta. It doesn't matter. Okay, we don't need to label these sides at all. Just remember the idea, okay, that I told you. Right, so Pete, what's always the first thing that comes after the equal sign?
Half.
Yep.
Half of,
We always put 1/2.
right.
So 1/2. Angelina, what would come next? Do we use the sides next, or do we use the angle next? We're going to use the sides. So what are we going to put in those two spots?
3 and 4.
3 and 4. Okay, and then how about Ben? What trig function do we use? sine. Okay, we're not using cosine, we're not using tangent, we're just using sine. Sine of, and Jaden, what are we taking the sine of? Yeah, this already gave us the same angle again, but it's whatever the angle is. So since we know the sine of 30 from the last problem is 1/2, let's see if we can just do this without a calculator. So order doesn't matter when you multiply, so I'm going to do it what I think is the easiest order in my head. James, what's 3 times 4?
12.
12. So we have 1/2 of 12. Okay. And now we're going to do 1/2 of 12, which gives me how much? Mateo? 6. Sine 30. And we just did sine 30 in the last problem, and that came out to 1/2. So what's my final answer? Okay?
3 squared.
3 units squared. Again, coming out to a nice answer that's usually not going to happen, but it did for the first two. Yes?
Maybe inches.
Yeah, that's right, because this one we do know the units. So since we actually know it, we should fill it in. Yeah, thank you. Great, questions on it? All right, let's see what else. That one. All right, let's try one more of those, and then we'll try a different type. So find the area, and this time they're kind of giving you a hint. It's not going to come out to a nice answer. So they're saying round to 2 decimal places. When they say round, that's a hint you're definitely going to need a calculator. All right, so Katrina, first thing that always comes after the equal sign is we're always going to put 1/2. 1/2. Jacob, what's going to come next?
The base and height.
If I knew the base and the height, I would, but I don't know the height.
2 parentheses.
Yeah, I'm going to put the 2 parentheses. This would be the height. For anyone that's wondering, I don't know that distance. So we're going to have to use the formula that we have now to do this. So what would go in those parentheses?
5 and 2.
Yep. So 5 you could think of as the base, but 2 is absolutely not the height. It's not. It's at an angle. Okay, so we got 1/2, 2 times 5. And Cassidy, what comes next?
Sine 20.
Sine of 20 degrees. Okay, since we're going to need a calculator, let's, well actually this part, what's 1/2 of 2? 1. So this part I don't even need to type in, because when you multiply 2 times 1/2, you're just going to get 1. So that just cancels out. If we don't want to type it in, you can. But now we're just going to type in 5 sine 20. Okay, see what we get. So 5 sine 20. And that gives me 1.71 square units. This time I don't know the units. So on the test, you'll probably have, I think, 4, maybe 5 questions that are just like that. Any question on finding the area when you have 2 sides and an angle? Okay. Let's look at this one. So it says we can also find the area of a triangle if all you know is the 3 sides. So if you're given the 3 sides, what are you missing that you have to have to use the formula we just learned? Yeah?
The angle between 2 of the sides.
The angle between 2 of the sides, which angle would you need? Yeah?
Not always have to be together.
No. Which angle could I give you here and you'd be able to find the area? Yep,
Any of the angles?
any of them. Doesn't matter, we could find any one of those three angles and then we're all set. This is a side, side, side triangle. Do we have a way to find an angle in a triangle if we know all three sides? Anybody remember what that formula was called? Can't do a right triangle problem with that because it's not a 90, so we can't use that. But we did learn something when we learned two laws, and one of the laws was for this type of triangle. Remember, yeah?
Now law of cosines.
It's law of cosines. We don't have to do the full problem. Usually when we had a law of cosines problem, we had to find everything. All the sides, all the angles. We don't need all the angles, we need one angle. That's all we need. All right. So just a reminder about what law of cosines is. A squared equals b squared plus c squared minus, does anybody remember what number came after the minus sign? It's minus, yep.
Is it pi?
Did you say pi?
Yeah, I thought it was around that.
No, it's not pi. It's just it's a nice number. Minus, yep. 2. And then there were two letters right here. Anyone remember the two letters that went right there? Yeah. BC times the cosine of the angle across from the letter we started with, alpha. And this is like area formula. You can write this three different ways. One side squared equals the sum of the other two minus twice the other two times the cosine of the angle across from what you started with. I started with A, alpha is across. Right, so I'm choosing to find that angle right there. It doesn't matter which angle you choose. Just find one of them, and then we're all set. All right, so let's kind of fill it in as we go. So A squared. James, what's A squared?
64.
64 equals. Lacey, what's B squared? 16. And Raymond, C squared? 25. Minus 2 times B times C. 2 times 4 is 8. 8 times 5 gives me how much? 8?
40.
40, good. Cosine alpha. Okay, Autumn, any like terms that I can add up on the right side?
16 and 25.
Yep, just the 16 and the 25. Remember that negative 40 is being multiplied, so you can't touch that. 16 and 25 gives me 41. All right. Jess, what would I do next here?
You would subtract 41.
Yep. Subtract the 41. That's going to give me 23. All right, and now I have 2 steps left. Mateo, what would be my next step?
You add the 40 to both sides.
If we had like a plus sign in here, then adding 40 would be the opposite of subtracting 40. But what operation do we have between the negative 40 and the cosine?
Multiplication.
So what's the opposite of that?
Division.
So we want to use division. And what would you divide both sides by?
23.
So we're not trying to move stuff back over here. We're trying to take everything that's near the alpha and move it away from it.
What do you do the minus 40.
Yeah, the minus 40. I don't want that on that side anymore. And I'm going to leave that as just 23 over minus 40. And what's my last step? To get rid of cosine. We've used this a lot. Yep.
Inverse.
Inverse cosine. Okay. So as far as kind of the extra work for that problem, that was it. That's all we had to do. And now we'll have the angle. So our area equals, I know I need to find that angle. I'm going to find it in a second. 1/2. Now we just have to look at what two sides did we use. We used, let's see, we solved for this. So those are the two sides we want to use. We solved for alpha, which is across from A. So you're always using the two sides and the angle between. So 4, 5, and alpha. 4, 5, and alpha I still need to type in on the calculator. Times the sine of the angle between them. Okay, and that's the inverse cosine of negative 23 over 40. All right, so inverse cosine, negative 23 over 40 gives me an angle of 125 point, we'll call it 125.1. Okay, that's going to round up. 125.1. And again, you didn't have to solve for that angle. You had to solve for one of the angles. But you could have solved for beta, or you could have done gamma. Okay. It would have changed which two sides you had to use when you did the area. But I chose to find alpha. All right, now we just type it in. Let's see, Jacob, what's half of 4?
2.
Times 5? 10? So I just did that part, so it's less I have to type in. And there's my answer. 10 sine 125.1. Sine 125.1. The area is 8.18. I just need to see, was I given a unit? Yes, I was. Vivian, what were my units in this problem? Feet. Yeah, units were in feet. So that's about 8.18 square feet. Alright, so the reason I showed you that one is because it really uses the same formula. You don't need to learn anything new to find the area where you know all the sides. You can use exactly what you already learned from today and use the law of cosines. I don't like the law of cosines. It takes too much time. We have to do all this extra work just to find one of the angles. So there's an easier way. We don't have to use law of cosines to find one of the angles. The downside is it's another formula you'd have to remember. Okay? But the upside is you wouldn't have to use law of cosines. All right? So you can choose which way you want to do it. So the easier way to find area when you know all three sides is to use Heron's formula. Heron's formula basically does the law of cosines for you. You don't have to do it, but you have to remember what the formula is. So the first problem we'll do is we'll go back and we'll do this one again. But we'll do it with Heron's formula, and we'll see if we get 8.18. That's Heron's formula. I still think that saves time from doing law of cosines. So this calculates the area of a triangle if you're given all the sides. Okay, so what do you think the A, the B, and the C are in that formula? Yep,
Or sides.
those are the sides. Okay, we've used those letters before. We also have this other letter, S. That's not a 5, that's an S. Well, S stands for, I'll show you in a second. So A, B, and C are the sides. And what would you call it if you added A, B, and C up? What would that give you about the triangle? If you added up the A, the B, and the C? Yep. It'd give you the perimeter. Well, S is what we call the semi-perimeter. What does that mean? It's half the perimeter. So S is when you add up A, B, and C, and then take half of it. So there are 4 things you need to know to use this formula. S, A, B, and C. And if you use Heron's formula, law of cosines goes away. If you're ever taking the test and you forget Heron's formula or you didn't put it on your reference sheet, that's okay. You don't need it. You can still figure it out without Heron's formula. And we just did that in the last problem. I'm going to use Heron's formula from now on, because I think it's quicker. So, find the area of a triangle that has sides 4, 5, and 7. Okay, so we've got A, we've got B, we've got C. Aiden, what's the other letter we have to find? Yep, and can you, what is that again?
Semi-perimeter, so.
Yep.
1/2 of A plus B plus C.
1/2 of A plus B plus C. Well, 4 plus 5 gives me 9. 9 plus 7 gives me 16. And half of that is 8. Okay, so let's go back and look at that formula. It's the square root of S times S minus every side. Doesn't matter which side you do first. You got to do S minus A, S minus B, and S minus C. All right. Now, 4, 5, 7, is that the same? We should do 4, 5, and 8. Because if we do 8, then we could check our answer against the problem we just did. All right, so let's do 4, 5, and 8. Unless I'm going to do 4, 5, and 8 as the next problem. Let's see. We'll do it next. We'll just keep it simple. All right, so area. Square root of, first thing we put down is S. And now S minus every side. All right, how about Autumn, what's A? 4. And then S minus B. How about Cassidy, what's B? 5. And S minus C. Ava, what's C?
Seven.
7. Yep. All right, a little bit more we can do before we type it in. 8 times, all right, 8 minus 4. Well, Pete, what's 8 minus 4?
4.
4. 8 minus 5, Don?
3.
3. And Olivia, 8 minus 7?
1.
1. So let's type that in. We'll round it off and see what we get. All right, so square root of 8 times 4 times 3 gives me 9 About 9.8. About 9.8. I'm gonna go back up and just see if I had any units. Nope. Any questions on that? All right, now I want to do the same problem that we did here, where the sides are 4, 5, and 8. We already know the area should be 8.18. So let's check it now, but we're not going to use law of cosines. We're going to just use Heron's formula. Raven, what is my semi-perimeter here?
8.
How did you get that? What did you do?
The formula.
Okay, which is what is it to get the semi-perimeter?
It's a half, and then inside the parentheses is a plus b plus c.
Okay, so 1/2 a plus b plus c. We don't know which side is a, b, and c. We just have to add them all up. What's 8 and 5 gives me how much?
13.
Plus 4 more?
17.
And what's half of 17?
8.5.
8.5. Okay. So semi-perimeter is 8.5. And let's find the area. All right, James, what's the first thing I'm going to put under the square root?
8.5.
8.5. Okay, and Colby, next thing I'm going to put next to that?
8.5 minus 4.
Okay, so we did that one. We just said doesn't matter the order we do them in. Okay, Lacey, the next one.
8.5 minus 8.
Okay, so we got that one. And how about Angelina? What's going to be the last one? 8.5 minus 5. Okay, so remember, goal here is to get the same answer we got last time. Let's see. All right, so we've got 8.5. I don't want to have to type all those parentheses and subtraction signs in, so we'll simplify what we can. Jaden, what's 8.5 minus 4? 4.5. Okay, how about Aiden, what's 8.5 minus 8?
4.5. Or minus 8, my bad.
0.5, yeah. And Vivian, 8.5 minus 5? 3.5. All right, let's type that in and see if we get the same answer we got last time. All right, so square root of 8.5 times 4.5 times 1/2 times 3.5, and I get 8.18, which is exactly the answer we got when we did it with law of cosines. All right. So now, if you don't mind using a different formula, you can do area of all the sides without law of cosines. If you don't like that formula because it's just one other thing you have to remember, then don't use it. Do it the way we did it the first time. Any questions on that? All right. And all right, this will be the last thing we look at. So there's all kinds of special triangles. We have isosceles triangles, equilateral triangles. Well, let's see if we can use Heron's formula to come up with an equation that is special for an equilateral triangle. And since all the sides are the same, we can probably come up with a special formula just for this type of triangle. That's even simpler than Heron's formula. All right, what do we know about all the sides in an equalateral triangle? Yep.
They're all the same.
They're all the same. I don't know what they are in this one, so let's just pick a letter to represent them. I'm going to call that side x. Well, what does that mean the other two sides would have to be if it's equilateral? Equal to x. They're all x. So what I'm going to do now is I'm going to use Heron's formula on that and find the area. But because every side is the same, we're going to be able to come up with something that's a pretty simple formula for an equilateral triangle. All right, let's start with the semi-perimeter. Okay, so Raymond said it's 1/2 of the sum of all the sides. So 1/2 of x plus x plus x. Autumn, what's x plus x plus x? Ben?
We won't be able to know.
What is it?
We won't be able to know.
Well, just combine the like terms.
like
Yeah.
X squared.
3x. Yeah. Usually we say 3x. So that's x plus x is just 3x. So 1/2 of 3x. Well, I want to put that all together as one thing. And that's how you can write it as one thing. 3x divided by 2. Dividing something by 2 is the same as multiplying by 1/2. All right. So now let's fill in Heron's formula. Square root of, we have x. And you can put the x right next to it, you can put the x in the top, it's exactly the same thing. Same thing. Times, and what's going to go in each of those parentheses 3 times? It's going to be the same thing in 3 times in a row, because every side is the same. Yep.
3x over 2 minus x.
So we have this minus x, this minus x, this minus x. Now, just to think about it in your head, what's 3 over 2 as a decimal? Yeah?
1.5.
1.5. So every one of these in parentheses says 1.5x minus 1x. 1.5x minus 1x. 1.5x minus 1x. What's 1.5x? Take away 1x. What would you have left for x's? Yeah. 0.5x. 0.5x here, 0.5x here, 0.5x here. All the same. So, is 0.5 the same as 1/2 then?
Yeah.
Okay, I'm just going to write it that way. So, 0.5x, another 0.5x, and another 0.5x. Now, read what that says. 3/2 times x times 1/2 times x times 1/2 times x times 1/2 times x. That's all multiplication. Aiden, if I want to multiply all that stuff together, does it matter the order I do it in? No. So instead of having it written number, letter, number, letter, number, letter, let's put number, 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 number together, and then letter, 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 letter. So let's put it in that order. So we have 3/2 times 1/2 times 1/2 times 1/2 times x, 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 x. Okay, when we multiply fractions, we just go straight across the top. What's 3 times 1 times 1 times 1? Yeah.
3.
3. And 2 times 2 times 2 times 2. Well, 10.
Sorry, can you repeat that?
Just multiplying the denominators.
16.
16. All right. And what about x times x times x times x? Yeah,
X to the fourth.
that's x to the fourth. So we're starting to get something pretty compact here for the area of an equilateral triangle. I have to take the square root of that whole thing. The easiest way is to take the square root of each one separate. Okay. Does square root of 3 have a nice answer? Try to do that, Ava?
I'm not sure.
Are there two numbers you can multiply to get 3 that are easy to figure out?
No.
Vivian? No. So we're just going to leave that. How about square root of 16? Does that one come out nice? Yeah, what's that? Just 4. And the last one? Are there two things you could multiply together to get x to the fourth? Yeah.
X squared.
X squared and x squared. That is the formula for the area of an equilateral triangle. It only has one variable in it because every side is the same. X is the length of the side. Now, if you didn't want to use that formula, you could go back and use Heron's formula. That'll work fine. It's just Heron's formula is going to be a little bit extra work because you're doing the same thing 3 times in a row. So that's a shorter version. Now, which formula do you think is more useful? This one or Heron's formula? Why?
Because you can use it in more situations.
Yeah, this is very specific. This is only useful if you have an equilateral triangle. It doesn't work for anything else. Heron's formula will work for anything, okay? As long as you know the sides. All right, so let's say I said find the area of, let's do the area of that triangle. So we've got a special formula that's very, very short compared to Heron's formula, just for an equilateral triangle. James, what would I be filling in for x if I want to find the area of this triangle using that formula? 2. That's it. Square root of 3 over 4 times 2 squared. What's 2 squared, James? 4. Well, if you're going to multiply by 4 and then divide by 4, those just cancel out. So the area is just the square root of 3. And that's it. So it's a very fast formula to find the area of an equilateral triangle. And you could make formulas for every other kind of triangle there is. Isosceles, all kinds of stuff. That's the only one I wanted to look at. Okay, questions on that? So the two most useful formulas you really want to remember from this section are the first one, 1/2 the product of the two sides times the sine of the angle between, and Heron's formula. If you want to remember this, it's great if you have an equilateral triangle, but there are other ways to do equilateral triangles without this formula. Longer, but you can still do it. Okay. So that's the homework for tonight, like 6 to 16 even, 20, 22, and 33. Okay, I'm going to give you a hint on number 33. I'll scroll down in a second. Okay, number 33 is an area problem. want you to find the area of a certain shape. And what they want you to do is find the area of that section in blue. That's not really a shape we have a formula for. It's like the bottom side is flat and the outside edge is curved. But what we do have from today, we've learned how to find the area of a triangle, and they'll give you the information you need to find the green area. And we know how to find the red area. That's called area of a sector. Okay, we did that in the first week. So you can find the area of this red section using a formula we learned the first week, and then subtract the area of the triangle. What's going to be left is just this little part in blue. Okay, so that's my hint for number 33. Okay, you've got about 10 or 12 minutes. Okay, so if you do have any questions or if you want to start that, you've got a little bit of time. But again, if you need to come talk to me about your grade or you're concerned about anything, now would be a good time to come chat with me.